1.3, functions. We're going to talk about functions today. First of all, I need you to define domain for me. What is the domain? How do I find the domain? Domain goes with which axes? X or Y? X, good. X, good. So domain is the X axis. So it's how far something travels on the X axis. Okay, so it's what is my range tells me how far it's going on the X axis. It starts here and it stops here, or it continues on forever, whatever the case may be. So my range goes with what? The Y axis. Okay, how far on the Y axis? Okay, so it's going to tell me how high or how low it's going, where it starts, where it stops, if it's continuing forever. What is your input? When we do functions, what do we input to? We plug numbers into what? To the X. Okay, so my input is my X. Okay, so my output is my what? Your Y. Okay, in simplest form, those are those four definitions in the simplest form you can get. What classifies a function? What classifies something as a function? It's when I have every input has exactly one output. So something is a function when every input has exactly one output. So every X has exactly one Y. Okay? So every input has exactly one output. So we get to this right here. And they want us to look at this table of data and tell if it's a function or not by looking at it. Okay? Is that table of data a function? My X's go 2, 2, 3, 4, 5. My Y's go 11, 10, 8, 5, 1. Is that a function? Does every input have exactly one output?
Don't you do that test?
Yes.
You can do the vertical line test, yes.
Then it's a function, right?
Well,
Because if you, it's not over, right? It's down, or is it over?
this doesn't go with this.
Oh, no.
This is just data. Here. So they want you to be able to look at a chart and tell if it's a function or not without even graphing it. Here's the deal. I have X, my inputs are 2, 2, 3, 4, 5, yes? So I have 2 2's as an input. And the outputs are different. So is that a function? No. Not a function. Now, if the outputs were the same, this would be a function. But because they're not the same, because when I plug in a 2, I get an 11. When I plug in a 2, I get a 10. That is not a function. On here, I have this graph. I have -2, +3, -1, 0, 0, -1, 1, 0, and 2, +3. Is that a function?
Yes.
Yes, because I could do, first of all, I can tell that they're only plotted once. Okay, there's no double plotting. But I can also do the vertical line test. If I had connected this to make a parabola, and I do the vertical line test, it's only going to go through there once. So yes, it's a function. So you're going to have to be able to tell off of graphing things and off of charts if something is a function or not. Then we get to equations. And we're going to have to decide with equations if something's a function. Okay? To determine whether y is a function of x, you have to solve for what? Well, no, I need to get this into what form? Y equals form. So if I get this in y equals form, I always want to get everything in y equals form or in function form. So y equals 1 minus x squared. Okay, so I've got to decide if that's a function. So the easiest way to test that, if you would like to test that, would be to plug in like the same number, positive and negative, to this x to see if to plug in a number positive or negative to that x and see. So if I plug in a 1, I get y equals 1 minus 1, which is 0. So if I plug in a 1, I get 0. If I plug in a negative 1, okay, I'm going to also get 0. If I plug in 0, I end up getting 1. So if I were to graph this, I would have this, and then I would have negative 1, 0, 1, 0, right? I would have it like this. And I would have this type of parabola going on. Is that a function? Yes. Okay, this is a function. Now, if my parabola, or if I had not a parabola, but I had a hyperbola or an ellipses, it might, or an ellipses or functions like that, it's not going to be a function because I'm going to do the vertical line test. It's not going to work. Okay, how do I first have to do negative x plus y squared equals 1? How do I first have to get it into what form in order to see if it's a function? Y equals. So I get y squared equals x plus 1, take the square root, and y equals the square root of x plus 1. Okay, so if y equals the square root of x plus 1, okay, I can then figure out if that is a function or not. And remember, when you're taking square roots, you always have an answer of plus or minus. So if I plug in a 1, okay, I would have y equals plus or minus the square root of 1 plus 1. 1 plus 1 is 2, so y equals plus or minus the square root of 2. So I have 1 radical 2 as a solution, and I have 1 negative radical 2 as a solution. Is that a function?
No.
No. Not a function because my inputs have 2 outputs. Okay? My same input has 2 outputs. So it's not a function. When you are writing something in function notation, because they're going to ask you, put this in function notation, you need to know what things stand for. The x stands for my input. The f of x stands for my output, and then I combine it to make an equation. My f of x equals 1 minus x squared. So this is my output, this is my input. Okay? That is my output, and that is my input. So when you are looking at, you need to know that that is function notation, because they're going to ask you to place things in function notation. And then they're going to ask you, last thing that we're going to talk about today is to evaluate a function. Okay? Evaluate. You're going to evaluate something that says g of x equals negative x squared plus 4x plus 1. And then it says when you have g of 2, when you have g of t, and when you have g of x plus 2. So if they give you this and they say to evaluate, what do you think we're going to do? What do you think we're going to do? Here's my equation, right? This right here is my output. My input is anywhere there's an x. Okay? And what am I inputting for that right now? On part A, I'm inputting a 2. Okay? 2 takes place of the x. So I'm going to plug this in. So that says negative 2 squared plus 4 times 2 plus 1. 2 squared is 4. 4 times negative 1 is negative 4. Plus 8 plus 1. So I have 9 minus 4, which gives me 5. So my answer when I evaluate g of 2 is 5. My output is 5. My g of x equals 5. Then on B and C, they don't give you numbers, they give you variables. And you literally are doing the same thing. I'm plugging t anywhere there's an x. So I end up getting negative t squared plus 4t plus 1. I cannot take that any further. Okay? That is my solution in that case. It's as far as I can take it. And then the final one is I'm plugging x plus 2 into anywhere there's an x. So you have negative x plus 2 squared plus 4 times x plus 2 plus 1. Now here you have to FOIL because you have x plus 2 squared. So you're going to change this to say negative x squared plus 4x plus 4 plus 4x plus 8 plus 1. We are distributing, we are simplifying. Everything here becomes negative. Going this way. So you have negative x squared minus 4x minus 4 plus 4x plus 8 plus 1. From there, I combine like terms. This is the only one that is x squared, so I get negative x squared. This is negative 4x, and I have a positive 4x, so they cancel. I have a negative 4, a positive 8, and a positive 1. So I get plus 5, right? And that is what you get when you plug in x plus 2 for the function g of x equals negative x squared plus 4x plus 1. You have to show me work. You have to do work on this. That's what we're doing when we do function notation. And that's where we're stopping today.